Hello Primary 6, how are you today? I hope you are fine. Today we are gonna to talk about Unit 1, Lesson 2. Unit 1, Lesson 2. And our lesson for today is called Law of Levers. Law of Levers. We have learned that any lever is a rigid bar that rotates around a fixed point called a fulcrum and is affected by an effort force F and resistance force R. Like this picture, the lever consists of fulcrum, effort force, resistance force. According to the type of a lever, sometimes we find that effort force is less than the resistance force, or the effort force greater than the resistance force. The effort force equals the resistance force. The mathematical equation that explains the relation between effort force and the resistance force is called law of levers. So, the law of levers states that the effort force multiplied by its arm equals the resistance force multiplied by its arm. So again, what is the law of levers? Law of levers states that effort force multiplied by its arm equals the resistance force multiplied by its arm. Effort force or force arm, what the meaning of effort force arm? It is the distance between the effort force and fulcrum. So again, force arm means the distance between effort force and fulcrum. The distance between fulcrum and the effort force is called force arm. Resistance arm, the distance between the resistance force and fulcrum. So again, resistance arm is the distance between the resistance force and fulcrum. When the force arm and the resistance arm are equal, the resistance arm equals the effort arm, the effort force is equal to the resistance force, and this lever doesn't conserve effort. So when the resistance arm equals the effort arm, the effort force is equal to the resistance force, and this lever doesn't conserve effort. But when the force arm is longer than the resistance arm, the effort force is smaller than the resistance force, and this lever conserves effort. So again, this is a very important point. When the force arm is longer than the resistance arm, what happened to the effort force? The effort force is smaller than the resistance force, and this lever conserves effort. Effort arm longer than resistance arm, so the effort force is smaller than the resistance force, so this lever conserves effort. And when the force arm is shorter than the resistance arm, what happened to the effort force? The effort force is larger than the resistance force, and this lever doesn't conserve effort. As we see, when the force arm is shorter than the resistance arm, so the effort force is larger than the resistance force, and this lever doesn't conserve effort. The effort force and the resistance force are measured in Newton. The force arm and the resistance arm are measured in meter or centimeter because they are distance. The factors that determine the value of force and resistance are the force arm and the resistance arm. Examples: a force whose value equals 50 Newton affects a lever of the second class lever. That is force arm equal 20 centimeter. Calculate the resistance force where its resistance arm equal 5 centimeter. Let's see. First, we will say the law of lever. Law of lever say effort force multiplied by its arm equal resistance force multiplied its arm. So effort force equal 50 Newton. 50 multiplied by its arm, 20 centimeter multiplied by 20. Equal resistance force multiplied by its arm multiplied by 5. So the resistance force equal 50 multiplied by 20 divided on 5 equal 200 Newton. Another example, a force whose value equals 20 Newton affects a lever of the second class lever. That its force arm equal 10 centimeter. Calculate the resistance force where its resistance arm equal 5 centimeter. Let's see the law. The law says the effort force multiplied by its arm equal the resistance force multiplied by its arm. So effort force equal what? Equal 20. So 20 multiplied by its arm equal what? Equal 10 multiplied by 10. Equal resistance force multiplied by its arm by 5. So the resistance force equal 20 multiplied by 10 divided on 5 equal 40 Newton. Law of levers and conservation of effort. Some types of levers conserve effort or has a mechanical benefit, while some other types of lever don't conserve effort. Let's see. By applying the law of levers on the three types of levers, we find that first class levers, there are three possibilities in this type of levers, which are possibility number 1, the force arm is shorter than the resistance arm, as we see. So the effort force is larger than the resistance force. So in this case, in the first class levers, in this possibility doesn't conserve effort or has no mechanical benefit. So again, when the force arm is shorter than the resistance arm, the effort force is larger than the resistance force, and in this possibility doesn't conserve effort or has no mechanical benefit. Possibility number 2, the force arm is equal to the resistance arm. When the force arm equals the resistance arm, so the effort force is equal to the resistance force. So the first class lever in this possibility doesn't conserve or doesn't save effort or has no mechanical benefit. Possibility number 3, when the force arm is longer than the resistance arm, the effort force is smaller than the resistance force. So in this possibility, the first class lever in this possibility conserve effort or has mechanical benefit. Sometimes the first class levers save effort. Why? Because sometimes in the first class lever, the force arm is longer than the resistance arm. So the effort force is smaller than the resistance force. So the lever in this possibility will conserve effort. Second class levers. This type of levers always save effort or has a mechanical benefit. Why? Because the force arm is always longer than the resistance arm. So the effort force is always smaller than the resistance force. The nutcracker and wheelbarrow save effort or have a mechanical benefit. Why? Because the force arm is longer than the resistance arm. So the effort force is always smaller than the resistance force. As we see, so in the second class levers, all the time, all the types of second class levers save effort Why? Because the force arm always longer than the resistance arm, and the effort force is always smaller than the resistance force. Third class levers. This type of lever don't conserve effort, has no mechanical benefit. Why? Because the force arm is always shorter than the resistance arm, so the effort force is always larger than the resistance force, as we see. But all the third class levers and some of the first class levers that don't save effort, that have no mechanical benefits, are beneficial other things, as we can use it in increasing distance, increasing speed, avoid dangerous accuracy in performance. See you in the next time. Goodbye.